This video is about how to determine the proper name of a binary ionic compound using Roman numerals. So the first thing in all of this is to make sure you have a binary compound, which means there's only two elements. A couple of examples. NaCl, that is a binary compound. It's ionic, and we'll determine why in a sec. H2O, that is also a binary compound, but it is not ionic, and we'll determine that in a second. C6H12O6 is not a binary compound because it's got three elements. So once you determine that you have a binary compound, then you decide what type of compound it is. Is it ionic or is it covalent? To determine that, you ask yourself, is the first element a metal? That's the simplest way. Sometimes there's an exception to that, but we're not going to deal with that right now. If the first element is a metal, then you have an ionic compound. So NaCl, Na is a metal, therefore NaCl is an ionic compound. H2O, H is not a metal, therefore this is not an ionic compound, and that works for most cases. There again, we'll have the exceptions later. Once you determine it's ionic, the binary compound, then you determine whether or not the metal is a transition metal or other metal that has multiple possible charges. Here are a few examples of ones that do have multiple possible charge. They are iron, nickel, copper, silver, mercury, tin, and lead. There are a few others which I have highlighted in highlighter yellow here that you'll probably deal with before we're done. But for now, these will be enough. Once you've determined that your metal is one of the transition metals that has multiple possible charges, you know we're going to have to use a Roman numeral in the name. Otherwise, we'll have a slightly different lesson. So, to put the Roman numeral in the name properly, you have to make sure you get the charge right. To do this, we need to make sure that we determine the neutral compound. Okay, the charge of the nonmetal has to be determined first. The reason is because the whole thing with the Roman numeral is you got to figure out what the positive charge of the metal is. So to determine the nonmetal charge, you go to the periodic table and basically you count how many places away from the noble gases your nonmetal is. For example, fluorine is one step away from the noble gas, so fluorine is a -1. Oxygen is 2 steps away from the noble gas, so oxygen is a -2. That works for most cases that we'll deal with. Once you determine the negative charge of your nonmetal ion, you just multiply that by the subscript of the nonmetal in the formula, and that will give you the total negative charge of the nonmetal in that formula. Then remember, we're making a neutral compound, so the total positive charge is equal to the total negative charge. Now you know the total positive charge of the whole formula, but you want to know the total positive charge of the formula so you can find out the positive charge of just one ion of the metal. So we're going to divide the positive charge total by the number of metal ions according to the subscript in the formula. Let me just run this by you real quick and show you how this works with sodium chloride. When we look at sodium chloride, we don't have to do this rule because sodium is not one of those special metals, but chlorine is a -1 nonmetal. We could determine that by looking at the periodic table. We can see that there's only one chlorine in the formula, so the total negative charge on this is -1. Therefore, the total positive charge is +1, and since there's only one sodium in the formula, the sodium ion itself has a charge of +1. Once you determine the positive charge of the metal ion from the formula, then you will write the positive charge as a Roman numeral in parentheses after the metal name. And here's an example of how this works. So we want to determine the name of PbS2. We remember from our list and from our periodic table that Pb is one of those special metals. This is a binary compound, therefore we're going to be using the Roman numeral names for this. So the first thing to do is we got to determine the nonmetal charge. We determined from our periodic table that sulfur is a -2 ion, and so we then determined that sulfur is in the formula twice. So we know that the total charge of sulfur in this formula is going to be -4. And we remember that we want to make neutral compounds, so the total positive charge of the lead is going to be +4. So we now know the total positive charge of lead, but what's the charge of just one lead? Because there's only one lead listed in the formula. So the total positive is +4. There's only one lead in the formula. Therefore, the charge of that one lead must be +4. So now we know how much the charge of the lead is, so we can write the name. Lead, Roman numeral 4, sulfide. That's it. You just take the name of the metal off the periodic table, you add the Roman numeral determined by the charge, and you just chop off the end of the non-metal name and add IDE to it. Sulfur becomes sulfide. Hope it helps.